when we're talking about polar form, we might sometimes want to find our directional angle theta. Now, what are we looking for here? We're looking for this counterclockwise angle from the positive x-axis. That is our theta. That's always going to be our theta, the one that works in this formula. We call it the directional angle. So I can write that for you. That's what we want to find, the direction angle. All right, so if I'm given this and I say, all right, I'm going to go over 5 and up 5, so our x component is 5 and our y component is 5. So this turns into a right triangle trig problem. Given 5 and 5 for adjacent and opposite, find theta. Well, that sounds like a tangent problem to me. Tangent of theta equals opposite over adjacent. Tangent of theta equals 1. So theta is inverse tangent of 1. Remember, tangent of an angle is a ratio. They gave us that ratio. Of course, this is 45 degrees. Remember, we've got some limitations on inverse tangent. It's only going to give us, if we're doing a practical problem like this, it's only going to give us an angle in the first or the fourth quadrant. So you've got to be careful of that. We're fine here because our question was in the first quadrant, but we'll have to take some immediate action if we don't get the quadrant we're looking for. And here is the trick. If you know you're looking for a third quadrant angle, so you know the angle's in the quadrant 3, and tangent is spitting out, say it was spitting out 45 degrees, and you know you want this angle down here. Well, the period of tangent is 180 degrees. So just add 180 to your answer. Same thing in quadrant 2. Say you know you want an answer in quadrant 2. Well, tangent will give you the answer in quadrant 4. So if you know it's in quadrant 2 and you get the answer in quadrant 4, then add 180 to your answer to get to the correct quadrant. So that underscores the importance of always knowing which quadrant we expect our answer to be. Find the directional angle theta for u equals negative 3i plus 3j. Well, look what they've given us. They've given us the x component and the y component. So they're telling us from 0, 0, go negative 3 and 3. And so here is our directional angle theta. Well, we can do a simple trig problem, right? Right triangle trig. We know tangent is opposite over adjacent. So I can say tangent of this angle equals 3 over negative 3. So tangent of theta equals negative 1. And theta is inverse tangent of negative 1. Now, I know my special triangles in general go x, x, x root 2. So anytime opposite is equal to adjacent, I know I'm dealing with a 45 degree or pi over 4 reference angle there. I know that. So I know that that answer is 45 degrees here in quadrant 2, right? So I can tell you then, well, if this is 180 here, then that is going to be 135. That's an obtuse angle. What happens if I put this in my calculator? I get negative 45 degrees. Look what your calculator is spitting out. Negative 45 degrees. Of course it is, because we know, for reasons I think we've hit quite hard, that the range for inverse tangent is from negative 90 degrees to 90 degrees. You can't even reach 90 degrees. You will never reach 135 degrees. So if you're given negative 45 degrees and you know the answer from your picture is in quadrant 2, that's where I'm saying you have to make your adjustment. If you simply add the period of tangent along to your original answer, you'll get an answer in the correct quadrant, which is 135 degrees. Want to avoid this problem completely? Well, in this case, we can, right? If this is our vector u and it has this directional angle, and we know its components are negative 3i and 3j, so we have this set up. Of course, you could say This is 3, 3. This is going to be, our magnitude here is 3 root 2, right? And again, I'm using this idea for the 45, 45, 90 triangle. I have x, x, x root 2. So negative 3, 3, 3 root 2. Now, of course, that is negative, and the hypotenuse is always positive. That's how I'm getting my signs. To the left and up is negative, positive, and this is always going to be positive. So I could also say cosine of the angle is negative 3 over 3 root 2. So cosine of the angle is, these will cancel, give me negative 1 over root 2. So cosine of the angle is, if I rationalize that, I get negative root 2 over 2 by multiplying by a fraction equal to 1. Now, if I put this in my calculator, it will give me 135 degrees. Don't forget, that's the Muffin Man, right? So the output will give us 0 to 180, and you don't have to worry, as long as you're in quadrant 2 or 1, that the cosine, you'll have to do that adjusting at the end. But important to know why we're doing that adjusting at the end if you don't get the answer in the quadrant that you would like. Find the directional angle for V equals 3i minus 4j. So I'll draw a little sketch here. 3i minus 4j. Well, they give us the x component and the y component. And so we're looking for this angle here. It's a fourth quadrant angle, quadrant 4. So I'm expecting an angle between 270 and 360. If I don't get that, I know I've done it wrong because my angle is going to be a big angle here. All right, so I do tangent of the angle, this is the angle I'm looking for, is equal to negative 4 over 3. So our angle will be the inverse tangent of negative 4 over 3. So when we do this, we're going to get negative 53 degrees. There's our reference, there's our directional angle. Negative 53 degrees. Ah, yeah, but I want the positive counterclockwise angle. So what do I have to do? They're actually coterminal. So if I add 360 degrees to this, I'll wind up with about 307 degrees. So note, I'm not adding 180 here because I want this angle. So please don't just remember pat rules. Oh, always add 180. Well, no, because the inverse tangent is working on a set of assumptions here, or I should say restrictions. It only gives you quadrant 4 and quadrant 1, but between negative 90 degrees and 90 degrees. So of course, it can't go past this wall. Your doggy's got to play in the front yard. It can't go to the backyard. So it's not going to give you that. It's going to give you this, but you want the fourth quadrant angle. That's why you're adding 360 here, because you want it in quadrant 4. And so you want the coterminal angle in this case. By the way, would inverse cosine work here? No, it would not.